All right, thank you to everyone who has joined us this evening, and welcome to our EV Revolution in Ontario with QTRIC, a virtual event. I am Shehzada Sharo, an OSPI Exchange Hub ambassador at the Toronto location. I'm a graduate from the University of Waterloo, and at present I work as a data science software engineer. And I am really happy and excited to be here with all of you this evening. Before we begin, I would like to take a moment to acknowledge that we are coming to you from Toronto, which is in the Dish and Spoon territory, with the acknowledgement to their past and present and the traditional owners of this territory and their unique role in the life of this region. So Toronto is on the traditional territory of the Anishinaabe and the Haudenosaunee and the Wendat people, and is covered by Treaty 13 of the Mississaugas of the Credit First Nation. We pay our respect to their elders past, present, and emerging. As settlers, we are grateful for this opportunity to live, work, and play in this territory. So before we begin, I would like to make a shout out to our sponsors for today. On behalf of all OSPI members, thank you to our partners for your incredible and ongoing support of Ontario's engineering community. All right, in 2019, OSPI launched exchange hubs at some locations across Ontario. These 5 hubs were located at the University of McMaster, University of Ryerson, Queen's University, University of Guelph, and the University of Windsor. The intent is to provide the individual OSPI member with opportunities for collaboration on concerns relevant to engineering, regardless of their career stage, in a multidisciplinary environment on initiatives specific to geographic sectors. In saying that, OSPI's Toronto Exchange Hub has organized today's event, which is the EV Revolution in Ontario with QTRIC, which is the Canadian Urban Transit Research and Innovation Consortium, a virtual event to discuss Ontario's strategy for this heavy-duty EV revolution and how it will impact the infrastructure, the environment, and the engineering industry. So let's jump right into it. I'd like to introduce our speaker for today. Our speaker for today is Soumya Bhavsar. He is a project manager on the Pan-Canadian Hydrogen Fuel Cell Electric Bus Demonstration and Integration Trial, and we'll definitely have questions about this with him. So prior to joining QTRIC, he worked as an energy efficiency programming consultant and a policy researcher at OECD in Paris. He was also a thought leader at a co-founded sustainability education and consulting organization. Prior to his postgrad, he worked as an EPC project planner in the oil and gas industry in Canada and Malaysia. So before we begin, I just want to lay out the agenda for today. After myself, we'll give the Zoom to Soumya for about half an hour. Afterwards, we'll have about 10 minutes for some of the curated questions that we have. All of you who are joining us right now can put your comments or questions into the live chat, and Natasha will be kind enough to sort them out and ask at the end. And right about 6:55, we'll have like 5 minutes for a short summary from my end. All right, Soumya, thank you so much for being here. And the Zoom is all yours.
Yeah, thanks a lot, Shah. Thanks a lot for the introduction, and thank you to the Ontario Society of Professional Engineers for this opportunity. I'm pleased to participate. So just to add a bit to Shah's introduction here, well, I am much more of, I come from quite an interdisciplinary background. Well, my bachelor's education involved industrial engineering, but I've never really designed any piece of equipment before. worked as a planning engineer for a while, and then moved on towards the softer sciences in recent years, delving a bit into energy economics and policy and sustainability issues. That said, in my present role, I manage the Pan-Canadian fuel cell bus demonstration and integration trial. And so I'll shed a bit of light on that project as well through the presentation. But yeah, I'll represent the Canadian Urban Transit Research and Innovation Consortium. We're driven by a vision to make Canada a global leader in low carbon smart mobility. And so you may have come in with expectations to learn more about the EV revolution, maybe as far as light duty vehicles are concerned. But yeah, because as an organization, we focus much more on public transit and heavy duty vehicles in general. I'll shed a bit of spotlight on heavy duty public fleets and especially some of the lessons we've learned working with transit agencies and especially transit agencies in the GTA. Moving on, just a quick introduction about the organization, and I'll introduce the organization here just so it gives you a bit of an idea of where I'm coming from when I say certain things. And so, yeah, QTRIC is a consortium of transportation innovation leaders started in 2015. We're just like many other nonprofits that are membership-based, and so we have 130 to 140 members hailing from industry, consultancies, the utilities as well as transit agencies, one of our backbones and foundations, and other not-for-profit organizations. And so we do have operations across Canada, and our focus is on low-carbon smart mobility and especially tech innovation, with a focus on actually expediting the commercial deployment of zero-emission buses at Canadian transit agencies. And so, we do have some marquee commercialization projects that the organization's been working on for the past several years. The two big ones would be the Pan-Canadian e-bus demonstration and integration trial, which is actually under implementation right now. It's under the empirical analysis phase. And the other one would be the Pan-Canadian fuel cell bus demonstration. And so we're yet to launch the project. We're in the process of launching the project. We're working on securing government funding and ultimately in the process of launching a capital project associated with a fuel cell bus deployment at the city of Mississauga. We do have other commercialization projects as well, a national smart vehicle demonstration project, and something we call the ACES Big Data Trust, basically a data trust of all interesting data that we would ultimately gather from the Pan-Canadian e-bus demonstration and the fuel cell bus demonstration projects to ultimately compare, how different cities are showing performance for buses, and also to compare predictive modeling versus empirical realities. And so if I was to start off with a bit of a snapshot about the ZDB scene in Canada. Now, you may be surprised to see some big numbers here, but I'll explain why that is the case. We're looking at almost, okay, first of all, let's put the CNG buses aside. I understand we're focusing on electric vehicles at this session right now. End of the day, CNG buses, if run through renewable natural gas, can be carbon neutral or carbon negative at times, which is why we do include CNG buses in our snapshot here. But if I was to look at electric buses specifically, we have almost 600 battery electric buses either planned, pronounced, or under the feasibility assessment stage, or under the procurement stage, or already deployed on Canadian roads. And going by the same approach, we see roughly 18 fuel cell electric buses basically planned at 2 transit agencies in Canada. That'd be Winnipeg Transit and Mississauga Transit. And so these buses are not yet deployed. They're still under the feasibility assessment stage, as well as financing and securement of funds is in progress for these buses. But yeah, 600 battery electric buses, it's a big number. We do have transit agencies where buses have already been deployed, but as far as on-road buses are concerned, we have not more than 100 buses on roads in Canada, and the rest of the buses that you see on the 600 statistic, they're basically big pronouncements from transit agencies in the GTA, especially. And so I hope that gives you a snapshot. Now, how does this translate into how does this translate into changes in infrastructure? How does this translate into an environmental footprint, and ultimately jobs, especially when it comes to engineering jobs? Before I delve into the impacts on infrastructure and so on, I'd also like to highlight a bit more on the background. So what's driving these pronouncements of zero emission buses, or what's driving the deployment of these zero emission buses? First of all, we now have municipalities or city councils starting to put forward ambitious climate action plans with ambitious targets as well. And in addition to that, recently the federal government of Canada also announced a plan to put forward $2.75 billion in funding, especially for zero emissions transit, with a goal of deploying 5,000 zero emissions buses on Canadian roads by 2024. So some ambitious targets here already. In addition, the Ontario provincial government has also been focusing on zero emissions transit very recently, and some recent announcements have also revolved around participating much more actively, especially in the automotive manufacturing sector when it comes to zero emissions vehicles. And so this is, I hope it sheds a bit of light on the background that is driving parts of this transition. And further on, besides some ambitious targets, there's additional funding programs and regulatory instruments that are also supporting the transition to zero emissions buses, and also ultimately towards light duty zero emissions vehicles as well. I will get to that in a bit here. But so yeah, let's have an overview of the impacts of a so-called ZDB revolution on infrastructure requirements. Now, if you were to break down the impacts, first of all, we could have a look at the energy and fuel generation infrastructure. That's one area of impact. There's impact on transmission and distribution infrastructure. Of course, we'll need to add capacity when it comes to transmission of electricity to transit agency parking garages. We'll also have to add infrastructure when it comes to distribution of fuels such as hydrogen to support, basically to support zero emissions buses. We'll also need additional charging infrastructure. Now, this could be at the bus depots, or we may need opportunity charging infrastructure. Now, what's going to dictate, depot charging or opportunity charging requirements? Based on our experience so far at QTRIC, especially now, our experience comes from a lot of zero emissions bus feasibility studies and a lot of predictive modeling. Well, we understand that to reliably transition to a zero emission fleet, a transit agency could be looking at anything from a 50-50 to a 70-30 mix between fuel cell electric buses and battery electric buses if they wanted to go 100% zero emission, at least at the tailpipe. And so basically, these numbers or these statistics are determined based on the design of blocks or routes at these transit agencies. And so if these transit agencies were to transition to zero emissions fleets without changing their existing block designs, basically a block is a combination of routes where a bus is deployed on a day-to-day basis. And so without really changing block design or existing block design, if a transit agency wanted to transition to a zero emission bus fleet, then what's possible, what's not, by just deploying chargers or hydrogen fuel dispensers at bus depots. That dictates the potential fleet mixes for the future. And they could range anywhere from 50-50 to 70-30. Less so, basically, there'd be less of an accommodation of battery electric buses, given that especially in heavy duty cycles, battery electric buses much more likely to get discharged before completing certain blocks. And I would also add that when it comes to heavy duty cycles, especially in medium duty cycles, what I mean by that is basically the buses operating with a full passenger load and the buses operating to cater to auxiliary loads in harsh or the worst case summer and winter conditions. Now, when it comes to the technology to support auxiliary loads, occasionally you could retrofit a bus with a diesel heater to minimize draw of energy from the batteries or from the hydrogen fuel tank ultimately. But we're in a world today where BEV or FCEV technology has matured enough that most manufacturers do provide these buses, these zero emission buses, wherein auxiliary loads are also catered to using the onboard battery on the zero emissions bus. Now, with this established, while we're using a pure zero emissions bus, the next thing to assess is whether or not we can actually function using only charging or fueling infrastructure at the bus depot, or if we'll need opportunity charging infrastructure. And so from our lessons learned, 30 to 50% of your fleet could be electrified using only depot charging infrastructure and without disrupting existing transit operations. Now, obviously, and quite possibly, a transit agency may end up having to change their operating patterns, and they may end up having to deploy opportunity charging infrastructure instead of purely relying on chargers or fueling at the bus depot. And so basically these calculations ultimately dictate how infrastructure will be reshaped as we move towards electric buses. And then, of course, if we were to elaborate this, as we move towards electric vehicles in the light duty segment as well. Now, if I was to start with the energy and fuel generation side, of course, as light duty and heavy duty electric vehicles start replacing conventional vehicles with rising electricity demand, not just in Ontario, but throughout the country, we will require additions to existing electricity generation, or alternatively, depending on the type of zero emission vehicle that takes over the market, we will be seeing an increased demand for alternative fuels, such as green hydrogen, possibly blue hydrogen, and maybe gray hydrogen as a backup. If I was to shed a bit more light on the hydrogen side, we're much more likely to see a demand for electrolyzers to be deployed either at transit agency premises or alternatively centralized electrolyzer facilities, which generate green hydrogen using the power grid from the province. Alternatively, we could also have a demand for slightly higher emissions fuels such as blue hydrogen, which rely on carbon capture technology, and so we may also see a demand for fuels like blue hydrogen, which will basically mandate deployment of carbon capture units on top of steam methane reformers at existing hydrogen generation facilities. Existing hydrogen generation mostly happens at refineries at the moment, but that landscape may start reshaping as well as we move towards zero emission buses. Secondly, when it comes to transmission and distribution infrastructure, of course, addition of distribution capacity, substations, and charging infrastructure on bus depots as well to cater to battery electric buses. And alternatively, if we look at the fuel cell electric side, we may also see requirements for scalable distribution infrastructure. In present day, we're seeing options such as tube trailers and basically tube trailers that can distribute hydrogen for smaller scale operations. But in the future, as we advance, we may likely see requirements for pipelines. And so that is one area where new jobs are likely to come in as well. But yeah, besides that, the other area to look for changes in infra impacts, of course, how bus parking facilities will reshape and how infrastructure at bus parking facilities will require to be shaped up, especially keeping in mind scalability and upfront capital costs and ultimately, fueling costs of the fuel of choice. And so these will drive forward infrastructure choices by transit agencies and infra deployment, especially at the end use of these alternative fuels. And ultimately, just to shed a bit more light on opportunity charging. So opportunity charging may mean having new opportunity charging infrastructure at existing transit hubs, or basically having chargers on the street so that buses could be recharged at certain points in their existing operating blocks or routes, as there is an opportunity for a quick recharge while the bus continues on its daily operations. And so, yeah, these four areas are where we're likely to see a lot of changes in infra. Now, if you were to expand, the impacts of the EV revolution to the automotive manufacturing sector and supply chains and the extractive industries, of course, there's additional impacts on infra requirements there as well. But we're not going to focus on that here. For the time being, a quick snapshot of environmental impacts. Now, if we look at environmental impacts again, if we break it down, there's basically 3 to 4 different areas to focus on: fuel production, transmission and distribution, and parts and vehicle manufacturing, as well as tailpipe emissions. So if I was to look at the production side, I did mention an alternative fuel such as green hydrogen or blue hydrogen, and I also use the term gray hydrogen. Basically, what do these colors mean here? These colors actually do drive impacts on the fuel emissions impacts on the fuel production side. Well, gray hydrogen is basically production of hydrogen using steam methane reforming, a chemical process where you reform methane using steam. And well, it is a highly emissive process. So the alternative option is to have a carbon capture unit on top of it, and cut down emissions by almost 80% when it comes to the production of the hydrogen. And hydrogen produced in such manner is called blue hydrogen. And then the other option is to produce hydrogen through electrolysis of water using electrolyzers. And well, when it comes to hydrogen produced in such a manner, it is labeled as green hydrogen, and it is mostly a low emissions process, depending on where you draw your electricity from. But so that is an example of how the fuel production side, or how emissions on the fuel production side will be dictated. And also, if you're looking at emissions on the production of electricity or the electricity generation side, of course, how your grid shapes up in the future and how your electricity mix shapes up in the future will dictate emissions when it comes to supplying energy to battery electric vehicles and battery electric buses. As far as Ontario is concerned, it is mostly a zero emissions electricity mix, roughly 55% coming from nuclear, as most of you may know, followed by roughly 25% coming from hydro, I believe, and then there's a chunk that comes from wind and solar, and about 5 to 6% for additional baseload support coming from natural gas power plants. And so how this electricity mix evolves will also dictate the emissions performance, or the life cycle emissions performance of battery electric buses, or how hydrogen supply shapes up will dictate the emissions performance of fuel cell bus or fuel cell vehicle technologies. Secondly, if you look at transmission and distribution, when it comes to transmission of electricity, we're not going to focus too much on that. But if we look at a fuel, an alternative fuel such as hydrogen, until there is reasonable scaling, where we can start using pipelines to transmit and distribute hydrogen, what we're likely to use or distribute hydrogen using trucks. And so that will contribute towards emissions to an extent. But as hydrogen demand scales, we're much more likely to cut down on emissions generated from transmission and distribution of the new fuel to endpoints. And so, of course, fuel, basically emissions from the life cycle of the fuel itself will be dictated by how new fuel consumption hubs shape up as well. Now, when it comes to parts and vehicle manufacturing, now that is a whole other interesting domain, and maybe slightly less talked about as well. But of course, it's got its own emissions footprint. And so if we look at parts and vehicle manufacturing, as most of you may know, battery manufacturing does use rare earth elements. And so the footprint, the emissions footprint of the extractive industries that contribute to battery manufacturing and maybe to other parts manufacturing is likely to remain reasonably high. However, if you were to look at the overall life cycle emissions footprint for a battery electric or a fuel cell electric bus, you can still expect a zero emissions bus or a zero emissions vehicle to substantially bring down emissions compared to conventional vehicles. And then besides the parts and vehicle manufacturing, we've also got the tailpipe emissions. That is one area where we can comfortably, or almost comfortably say that battery electric and fuel cell electric vehicles are highly likely to be zero emissions at the tailpipe. And I say highly likely only because there may be some emissions, not specifically from a tailpipe, but some emissions depending on whether or not you end up using a diesel heater to cater to heavy duty operating cycles. And so that may end up adding a bit of an emissions footprint when it comes to zero emissions vehicles in heavy duty and especially in transit fleets. A quick look at the impact area, which is the economy, and especially seeing how made in Canada jobs may evolve. Now, I've tried to break this down a bit. I've tried to break it down into the TRL or the technology readiness levels. So basically jobs in the different TRL levels, and then jobs, when it comes to the vehicle side and the energy supply side. And so in the bottom half, you basically see likely jobs or the areas where engineering jobs may emerge going forward. When it comes to the early TRL levels, the early technology readiness levels, mainly research, development, pilot and demonstration projects. And then in the top half, I've tried to highlight emerging jobs when it comes to commercial deployment of infrastructure and vehicles as far as the EV revolution is concerned. So in the early TRL level, when it comes to RDND, on the vehicle side, of course, there's a lot of research opportunities in the battery and fuel cell technology domains. Basically, the chemistry and, of course, the testing side of these technologies and the associated drivetrains as well. And there's another interesting area where especially we function as an organization, predictive and empirical performance modeling of vehicles, fleets, and entire value chains, entire fuel supply and vehicle ecosystems. And so that's yet another, early TRL area where interesting jobs more on the data science side are also likely to emerge and will continue evolving. When it comes to energy supply technologies, of course, there's there's up and coming opportunities when it comes to charging and hydrogen dispensing technology. But besides that, the more interesting would be how distribution equipment evolves, and on the process engineering side, for folks more focused on the chemical engineering side, there's also interesting opportunities emerging, to assess how best to transport alternative fuels such as hydrogen, not just domestically, but in the export markets as well. So yeah, when it comes to options like LOHCs, basically carriers for hydrogen, different substances to export or transport hydrogen, and then when it comes to distribution equipment, how material sciences jobs will evolve when it comes to developing equipment and systems to transport or transmit alternative fuels such as hydrogen. And then ultimately, when it comes to the energy generation side, there's interesting opportunities in the RDND of CCUS technologies and electrolyzer technology as well when it comes to improvement of these technologies. And I mentioned CCUS because going by the pace of change and going by the extent of ambition and going by how transition pathways may end up working out, CCUS may still be a go-to option in the energy transition. And so, yeah, quite possibly you may see continued focus on RDND opportunities on the CCUS side as well. When it comes to commercial deployment, some jobs have started emerging on the commercial deployment of vehicles and energy supply infra as well. So if we were to look at vehicles specifically, there's obviously jobs in the extractive industries as battery supply chains start expanding. But then there's opportunities in the parts manufacturing and vehicle assembly side, of course. One of our project partners, New Flyer, is an example. New Flyer Industries is a bus assembly company, and New Flyer is one of the leading suppliers of battery electric and fuel cell electric buses in North America. And so, companies like New Flyer, as they start planning to expand their assembly lines to cater to more transit agencies, as an example. There's interesting opportunities likely to emerge on that side as well. There's also going to be opportunities on fleet transition planning, and not just transit fleets, but heavy duty fleets at private sector companies, or maybe trucking fleets, as an example. And so fleet transition planning is an interesting area as well. And then ultimately, new opportunities emerging when it comes to procurement, operations, and maintenance as these vehicles and fleets are scaled. And ultimately on the energy supply and deployment of infrastructure side, of course, a lot of EPC opportunities as the producers and distributors of energy start building confidence in fuel demand from these emerging and consumption segments. And so, yeah, interesting times ahead when it comes to especially EPC projects for charging and dispensing infrastructure. Those would be relatively small ones, but then especially EPC projects around transmission and distribution networks, and so expansion of grid when it comes to supply of electricity to different end consumer nodes, but also the evolution of existing gas grids, existing natural gas grids, and also addition of new grid capacity with a specific focus on hydrogen as an example as well. And then ultimately interesting EPC opportunities also when it comes to green and blue hydrogen generation, and also expansion of electricity generation in general, right? And so I hope it sheds a bit of light on the bigger picture. I do have a quick overview on the public policy landscape in Canada as well. And so this slide sheds some light on existing programs to support the transition to zero emission, especially when it comes to heavy duty and public transit. And so, yeah, when it comes to regulatory instruments, there's some interesting regulatory instruments on the horizon. So the federal carbon tax is one example, but instruments such as the Clean Fuel Standard will or is anticipated to start impacting the transition, and it's anticipated to start supporting the transition to zero emissions fleets as it starts pricing out emissions on diesel. And so as the premium between alternative fuels and conventional fuels starts shrinking, it will hopefully drive forward it'll hopefully drive forward a change to these alternative fuels as well. And so, when it comes to capital funding programs, on the other side, we've got some interesting capital funding programs recently deployed by the federal government as well. The Zero Emissions Transit Fund is one. We've got the Invest in Canada Infra program, which also additionally supports capital infra projects. We've also got interesting programs from NRCan, the Clean Fuels program. We've got the ZEVIP program, Zero Emissions Vehicle Infra, wherein there's capital grants available for refueling and charging infrastructure, not just for public fleets, but I'd say charging points or fueling stations catering to private vehicles as well. And then there's some other capital funding programs such as those by Industry, Science and Economic Development Canada, Innovation, Science and Economic Development Canada, which focus on a variety of TRL levels, helping these new technologies to commercialize as soon as possible. SIF and its various streams would be one example in this instance. All this combined with some municipal action and up and coming provincial strategies as well, will hopefully drive forward a transition towards zero emissions buses and also light duty vehicles. And so, yeah, I hope this presentation gives you a bit of an overview of what's happening specifically on the zero emissions transit side, and then how it could potentially be elaborated to or extrapolated to light duty vehicles as well. So yeah, with that, I'll skip this for the timing. I'll move on and I'll pass it on to Shah again. Thank you so much, and I look forward to questions you may have, and especially any questions regarding the nitty-gritty of the technologies discussed here. I'd also be happy to take some of those questions offline. But yeah, in the meantime, I look forward to questions while we're here together in the webinar. Shah.
All right. Thank you so much, Soumya. That was very informative. And I think the first question I had was like, what are the biggest challenges? And I think the whole presentation sounded like there are lots and lots of challenges. So I'm just going to skip that question. And I'm just going to go down to the question that's going to, is important to Canadians most. Because what we are saying is that the prices for fares is going up only in one direction, and that's north, it's up. So what is QTRIC's plan, or you foresee that what do we need to do in terms of this fuel mix or whatever to bring the prices of these fares down when anyone is going to travel on these buses?
Oh, when you say fares, though, sorry, Shah, I just want to clarify, when you say fares, you mean ticket pricing to use public transit as an example?
Yes.
Okay, yeah, so fare pricing, it's another complicated beast. I must say that use of expensive zero emissions technology doesn't necessarily mean that a lot of those costs will be recovered through fare pricing alone. Especially post-pandemic, it is even more complex for transit agencies to actually recover some of these kinds of costs through fare pricing. With ridership having gone down already, and with a mammoth task ahead to first of all recover passenger loads, fare pricing is out of the option, and so that's where you look up to public support, basically support from all levels of government, and especially support from the federal government, either in the form of capital grants or either in the form of other regulatory instruments will be key to actually recover some of the costs of running these expensive fleets. Now, I must also say that when you look at the prices of these fuels, it is anticipated that battery electric buses will not necessarily be costlier to operate compared to conventional diesel buses. The more challenging technology will be fuel cell electric buses, depending on how many fuel cell buses a transit agency opts for in the future. But so yeah, if I was to ultimately answer your question, public funding support will be critical to cut down on price gaps, cost gaps.
All right, and that kind of like brings me to our second question. We were like forming these questions. The other important thing was what effect these buses are going to have on our grid. And from what I've heard so far is that we'll have a mix of, let's say, electric buses and hydrogen fuel cell buses, and then we have the old combustion engine running. Wouldn't these at a particular time balloon the costs? Because we'll have so many technicians and people looking, looking after these buses, and then we have different types of energy mix, and we're also talking about capturing that carbon. Kind of like we need more capital for this. So Do we have a blueprint that, okay, how much capital is needed to offset these emissions?
Blueprint. Well, so while we're in the process of launching a bunch of these demonstration projects, we're actually trying to establish blueprints. So over the next 5 years, well, these are some of the things that we intend to actually learn in reality. Now, yeah, ballooning costs is definitely a challenge. That said, if you look at costs, it's important to look at these costs comparatively. If you were to price emissions, diesel at the end of the day is an expensive fuel as well. And so as we start pricing emissions going forward, either through a carbon tax and also through instruments such as a clean fuel standard, it's not like conventional buses are going to be cheap to operate as well. And so it is critical to look at all costs associated with the energy transition by pricing carbon ultimately. And so if you compare the costs associated with these new technologies, even all the upfront costs for the infrastructure, end of the day, it is to cut down on future costs. What future costs am I talking about? Not just costs of using an expensive fuel, but we have a tendency to completely disregard rising costs of not acting towards mitigating the impacts of climate change. As you move forward, the less you mitigate the impacts of climate change, you're going to pay a large amount of money in adaptation costs as well. You're going to pay, as a society, you're going to be spending a lot of money on disasters and so on and so forth. So if you look at these upfront costs to transition with all this new infrastructure and compare it to maybe the costs of a changing climate 20, 30, 50 years down the line, I think it's a pretty reasonable thing to spend money on right now.
So pay now versus pay later, right? All right, so let's switch gears. I want to ask a question from my list about safety. Right now, a common man goes to a bus stop, maybe there's a small heater inside. Are there any safety concerns that we have these big, huge charging stations that grapple onto a bus, and we have high voltage electricity coming in, and then you also spoke about we'll have pipelines maybe to deliver hydrogen fuel to these buses at these stations. So, what do you think are the safety aspects around all these electrification?
Yeah. So when it comes to safety, of course. Your concerns are quite valid. The next area to focus on when it comes to ensuring safe and reliable operation of this new infrastructure, it is to work on design codes, and that is a gap in our existing efforts to move towards deployment of these new technologies. I mean, I'll refrain from getting into some very specific safety concerns, but as an example, of course, transmitting a fuel such as hydrogen, basically a compressed gas such as hydrogen, is of course a challenge. But we've done these things in the past with, things like natural gas, as an example. And so it's just a matter of transitioning to appropriate code standards for an alternative to what we've done in the past anyway. And yeah, maybe we may have done those things at a smaller scale when it comes to deploying charges and such. We need to rethink how a larger scale creates dangers and such. But I mean, ultimately, yeah, it's a gap that is necessary to fill in any transition. Safety and reliability, as much as a concern as it is, it is a gap that can be overcome.
All right. And, every now and then new terminology comes in. So with regards to QTRIC and their efforts in helping out Canadians, do we have like a roadmap for like Build Back Better Transit or something like this?
Yeah, just to ensure I understand. So do we, as in, does an organization like QTRIC have a roadmap to build back better and so on?
Yeah, that brings back
just
to the same question, like, do we have a roadmap? Because I'm sure you're working with different transit agencies
Yeah.
and they have different concerns on, how Mississauga Transit can work with TTC over here. So they're looking, or most of us are looking forward, getting a roadmap or some kind of a white paper to see, okay, this is the way we can move forward, and these are the costs, and these are the safety things. So do you have a roadmap when we will have that white paper in our hands?
Yeah, so, okay, good question. Yes, we do have a roadmap, or at least we have some solid priorities, and we understand our priorities much better. And so, QTRIC has also contributed a lot towards helping the federal government set up a roadmap alongside other stakeholders across the country. QTRIC's also played a strong role. Now, I will talk about a roadmap from the lens of commercialization of new technology. So our immediate priorities are to learn. How do we do that? We need a lot of demonstration projects. As much as we need early scale deployments of these new technologies at transit agencies to strengthen business case for supply of alternative fuels, we still need to learn a lot. We need to operate these new technologies on Canadian roads as much as possible. Just like one of my colleagues says, every bus has a story of its own. And so, we need to undertake a lot of demonstration projects, but these demonstrations, of course, don't necessarily have to abruptly stop the operation of these new technologies after they've spent some time and money to establish some lessons learned. We also have to start integrating these initial fleets into the long-term fleet operations of existing transit agencies. Now, how do we learn, and how best to implement demonstration projects? Well, your first priority, either as a transit agency or maybe as a user of another type of a fleet, should be to undertake robust planning. And so, what would robust planning look like? Of course, first of all, you want to predictively model and assess how either buses or other vehicles in your fleet may function in your existing under your existing operating conditions. So you want to undertake predictive performance modeling of these vehicles. Secondly, you also want to assess how supporting facilities need to evolve in terms of infrastructure. Number three, you also want to assess how fuel supply contracts or the contracting strategies for fuel supply will need to evolve. Number four, you would want to assess at what frequency to transition or to buy new vehicles, and how exactly to at what frequency do you want to transition from conventional, or at what rate you want to transition from a conventional fleet to a zero emissions fleet, and try to align that with infrastructure deployments at your supporting facilities. And at the end of the day, you also want to ensure that all your predictive modeling is done not just for one particular type of electric technology. You ideally want to have such modeling in place for all possible, all available electric technologies of vehicles. And especially when it comes to buses, we insist on BEVs and FCEVs both together. And so as you finish planning, the next step of course, is to, jump into assessment of funding and financing options, into an assessment of contracting strategies, into an assessment of total costs of ownership, and establishing a business case. That is an integral component of such planning as well. And so once you've completed such planning, it's then that you finally want to approach the funding sources that are available. Maybe start off with a demonstration project, and especially from lessons learned from the zero emissions bus consulting team and the commercialization team at QTRIC. Based on our lessons learned, we insist that you should probably start with 10 buses or more to ensure that the data that you are able to collect in your demonstration projects is robust and diverse. To also ensure that you're actually planning for the long term, and you are going to integrate these buses into your fleets. Once you scope out demonstration projects, you then want to focus on fuel supply chain planning, and also look at how you can align the timing of align and streamline the timing of increase in the alternative fuel demand, and the installation of supporting infrastructure. Over the 5-year horizon, as you learn more, and as you make the most out of public funding, it's then that you want to start scaling much more rapidly. You may also want to consider starting to scale in the first or second year of your demonstration and integration trial, as empirical data clarifies, that bus performance is reliable, that performance of an entire fuel supply chain combined with a bus fleet looks pretty reliable and reasonable. So that I hope that sheds a bit of light on a transition pathway. This is how organizations like QTRIC are highlighting how they can play a role in the transition to electric fleets, and how a transition should ideally happen as well. But in summary, just to strengthen a message, planning, a lot of focus on robust planning initially, before making a decision to get into a capital project. And we have funds available for that from our federal government, actually. So.
All right, that's great. Since we are short on time, I'll have one more question from the chat. Maybe you can quickly answer that. I know you've already answered about green, blue, and gray energy, so I'm just going to skip that question. So the main question is, since hydrogen is expensive to produce and dangerous to store, so during the presentation, we do see a strong message from your end for hydrogen as a part of this fuel mix. So why are you focused on that?
Why focus on hydrogen? Because it just makes sense. There are areas where you may see shortcomings from battery electric bus technology. And this in no way is meant to, vilify something, but, end of the day, going by how transit operations are set up, going by how range anxiety can be an issue, seeing how scaling charging infrastructure can be much more challenging compared to scaling hydrogen fueling infrastructure, especially on the transit agency premises. Seeing how there's also an opportunity to actually produce hydrogen on site, depending on real estate constraints and basically real estate constraints and opportunities at transit agencies. Hydrogen just makes sense, as a very important complementary technology. And so no matter how expensive it is, well, everything was expensive once, no matter how expensive it is, long as there's a strong tech rationale, it makes all the more sense to pursue hydrogen as well.
All right. Thank you, Soumya. Thank you so much for your time today. Had a wonderful presentation, and thank you for asking questions that our community at the Exchange Hub curated. Well, this concludes our virtual event for today. Again, I would like to thank you and Natasha and all of the members today who have taken their time to be with us and asked those really important questions. Thank you, all of you, and have a wonderful rest of the evening, and we will see you in the next event. Thank you.
Thank you, Shan. Thanks to OSPI. Please feel free to reach out in case you want to discuss any details about the projects we do or a bit more on the tech side.
Thank you.